All right, so in the last video, we introduced the idea of how to multiply rational expressions, and we went through kind of the process or the procedure to do that. We also worked through the first couple of examples. This video is just going to be 2 more examples, just so that you've got plenty of things that you can look at and consider and think about as you do these problems. So our learning objectives, identical to the last video. Just simply be able to multiply rational expressions together. That's it. This was the first example that we looked at in the last video, and we identified this basic process. First, we're going to start by getting rid of the 2 fractions and combining them into 1 just by going straight across. Once we do that, then we're going to simplify the same way we normally simplify. We go through each of the different things and try to factor them using greatest common factor first, and then any other method that might work. Once we've got them completely factored, then we cancel everything they have in common. And once nothing else factors and nothing else cancels, that's when we're done. Okay, so let's take a look at a couple more examples. The first example I want to look at is x squared plus 6x plus 9 divided by 6x times 4x squared plus 10x divided by 3x squared plus 10x plus 3. Oh, I'm sorry, I've got one little typo. This right here should be an x squared, okay? So I've got x squared plus 6x plus 9 over 6x squared in the bottom, 4x squared plus 10x, and a 3x squared plus 10x plus 3. Okay, so this is our first example in this video. Why don't you pause the video? The process is exactly the same as the last one. There's not a new process. So pause the video and give this a try first. All right, hopefully you've tried that. And if you're using the same basic procedure that I'm using, then you would start by combining across to make one great big giant fraction. Okay. Then once you've done that, you would go through each one of these bits and pieces individually and try to factor them. So right here, number 1, you might try to factor this with grouping. 1 times 9 gives me 9. Factors of 9, 1 and 9, 3 and 3. Factors that add up to be 6 would be 3 plus 3, and I could go from there. But you also might recognize x squared and 9 are both perfect squares. So this is something I could use my shortcut on. And since we haven't reviewed this shortcut yet in this series of videos, I'm going to take the shortcut method. So remember, the way that shortcut method worked was we're going to take the square root of both of these things. So square root of x squared is x, square root of 9 is 3. Okay. In the middle, in the middle, I'm going to keep this sign right here. And then I just write that whole thing squared. Okay, so in x plus 3 quantity squared. All right, so that takes care of my first one. In my second one, I have a 4 and a 10. Those can both be divided by 2. And both terms have an x in it, so I can factor out a 2x. Now, if I factor out a 2x, what would be left behind? Well, 2x times what equals 4x squared? That'd be 2x times 2x. And 2x times what equals a positive 10x? Well, that would be a positive 5. So there is the top of my fraction. Okay, in the bottom, I've got a 6x squared. Well, that's already factored, so I'm good there. And then I've got this thing. This one does not have perfect squares, so here I have to do it the long way. So I've got a 3 times 3 in this fourth one right here. 3 times 3 gives me 9. Factors of 9, and specifically I need the pair that add to equal 10, so that's going to be a 1 and 9. And I need them to add up to be a positive 10, so it's going to be a positive 1 and a positive 9. So this thing I'm going to rewrite as a 3x squared plus 1x plus 9x plus 3. Now I can factor from this first thing. My first group, I can factor out an x. That leaves behind a 3x plus 1. That tells me this has to have a 3x plus 1. So I must have factored out a positive 3. And so this whole thing becomes the 3x plus 1 that's in common times the x plus 3 that's not. So this fourth polynomial factors to become a 3x plus 1 times an x plus 3. Okay, so now we've got everything factored. We're ready to start canceling. All right, so notice I've got an x plus 3 in the top, I've got an x plus 3 in the bottom, but remember what squared means. It means literally I have two of these being multiplied together. So there's one in the bottom, but it's only going to cancel with one of the ones in the top. So my exponent goes from being a 2 to being a 1. Okay, now 2 and a 6, those cancel. 2 goes into 6 3 times. And then I've got an x in the top and I have an x times x in the bottom, right? Because that's what squared means, is x times x. So the one that's in the top can cancel with one of the ones that are in the bottom. And then that's it. Those are the only things that are in parentheses that match. So what have I got? I've got 1 x plus 3. And so I can make that 1 into a ninja. I don't have to write that out. These both canceled. Now I've got a 2x plus 5. In the bottom, the 6 canceled with the 2. That produced a 3. And then I have an x. Now it's to the first power. So I'm going to write that as a ninja, 3x. And then I've got this 3x plus 1. And that canceled. So this is it. This is my answer. All right, so there's my first extra example. Lots of stuff flying around to cancel. It's easy to get overwhelmed with these types of problems. So remember, like we say with all the problems that are lengthy in this regard, break it down into little bits and pieces and deal with it with one bit and piece at a time. All right, so there's example, our next example. Let's wrap this up with one final example. And this one is going to look a little bit different. X squared plus 49. I'm sorry, that's wrong. X squared minus 49. There we go. Over x squared plus 4x minus 21. So that's our first parentheses. X squared minus 49 over x squared plus 4x minus 21. And we're going to multiply this by an 4x squared minus 7x minus 15. Okay, so this one looks a little different. One of the reasons it looks different is because this is not a fraction. So let's think back to elementary school for a second. How can I take anything that's not a fraction and turn it into a fraction? Well, we just put it over 1. So that's the first thing that I would do, is just put this over 1. Now I can multiply straight across. So I've got an x squared minus 49 times my 4x squared minus 7x minus 15. And I've got a x squared plus 4x minus 21 times 1, which I'm just going to leave that as a ninja. And so there's my first step. Now I'm going to go through and factor each of my different bits and pieces. So this one I'll factor first. That gives me an x plus 7 times x minus 7 if I use my shortcut. Then I'll factor this one. I said first, but I wrote a 2. Look at that. That's the first one I factored. Now I'm doing this one. Now I'm going to factor this one. So these are not perfect squares, so I'm going to have to multiply 4 times 15. Well, 4 times 15, I believe that's 60, right? Yep, 4 times 15 is 60. So now I need all the factor pairs of 60 that will add, and I need to find specifically the ones that add up to be 7. So this is where I would go to Wolfram Alpha, and I would just type in the question, what are the factor pairs of 60? And now specifically, I'm going to look for the ones that subtract to equal 7. Okay, subtract to equal 7. So I think that's 5 and 12, right? 12 minus 5 equals 7. So 5 and 12, those are the two that I want to use. So back to my problem. I'm going to take this thing in the top right here, and I'm going to change that 7 into a 5 and a 12. But I need it to be a -7, so it has to be a +5 minus 12. So now I can factor my first group. They have an x in common. That means this has to be a 4x plus 5. Dividing, I must have factored out a -3. And yes, that checks. -3 and 5 is -15. -3 and 4 is -12. So I had a 4x plus 5 times an x minus 3 there. So 4x plus 5 times an x minus 3. Okay, down in the bottom, now I got to factor in x squared plus 4x minus 21. So that becomes the final thing that I need to factor is that one. And I'm going to have to do the same thing. I'm going to have to find the factors. 1 times 21, so factors of 21. Well, fortunately for that, there's not many. I think that's all of them right there. So the ones that subtract to equal 4, well, that would be 7 and 3. So I'm going to take this. I'm going to turn it into, I need +4, so I'm going to make it a +7 minus 3. So now in my first group, I get an x times x plus 7. In my second group, -3 times x plus 7. So it factors into an x plus 7 times an x minus 3. So that is what's in the bottom. Okay, so what can I cancel? Well, I've got x minus 3s and I have x plus 7s. So that leaves me with an x minus 7 in the top and a 4x plus 5 also in the top. In the bottom, that's over 1, right? Because when I have things that cancel, they leave behind 1s. And of course, anything divided by 1 is itself. So I can turn that 1 into a ninja and just write it this way. Okay, now I will say for the purposes of our class, I would probably mark this as correct and give this full credit. But notice what's happened on this problem. The fraction has gone away. This is no longer a fraction anymore. This is now a normal regular polynomial. And since our goal here was to multiply things together, remember in the land of polynomials, when we multiply things, we always write them in standard form. So technically, I should rewrite this in standard form, which means I'm going to have to distribute and combine like terms. So I'm going to get a 4x times x minus 7 plus a 5 times x minus 7 when I distribute my first parentheses. Then I'll need to distribute again. So 4x squared minus a 28x and 5x minus 35. Combining together my like terms, 4x squared minus 23x minus 35. Okay, now I will say, technically, all of this stuff that I have in purple is something that you should be doing. But for the purposes of our class right now, at this point in our class, the focus is on being able to work with the fractions. And so if you stopped right here, for the purposes of our class right now, I would consider that good enough. You've dealt with all of the fractions, okay? If you wanted to finish it and put it into standard form like you should, I probably would be willing to give a little bit of extra credit for that. Okay, so with that said, I think that covers everything that you will see in your next set of practice problems. So hopefully you found this helpful. Thanks for watching.